exponential growth and decay. So these questions are always talking about something increasing or decreasing. So it could be population, radioactivity, mass, temperature. It could be a whole host of things. But the main thing is to recognize them by these distinctive and quite complicated looking equations. So let's have a look at what each part of these equations are. Well, first of all, we should try and recognize them by these exponential to the base e parts here. Okay, so e, remember, is just a number. We've quite often got these p0 or c0 parts here, the thing in front of the e, and that should always be read as the initial value or the value at the start, the original value. And then we've got some variable up here, n here, in this case it's t. Usually that's a variable related to time, so it could be how many years, n years, it could be how many minutes or seconds. And finally we've got this variable here, which is after 10 seconds, what is the value now? After, let's say, 5 years, what is the value now? Finally, sometimes you have this value of k in there as well, and usually that's simply some fixed number which we will find out during the question. So now, bearing in mind that we've identified the variables, let's have a look at solving one of these. Okay, so let's do an example of this. I've actually gone for Heinemann textbook for this, page 299, 15H, question 7. I suggest that you get that textbook open so you can see the text, the sentences that I'm reading as I work my way through this. Now what I've done so far is I've copied down the formula from the question, get it on the page in front of me so I can have a look at it. Now I'm expecting that typically A0 is the initial value, T I'm going to imagine is time, K is usually just some constant that we're going to figure out very soon, and A is whatever the value is at now. Now when I read my question, I'm probably going to find out what backs me up here. So we've got A0 initial amount, K is a constant, T is for time in minutes. It's quite important to note the unit of time, so we're measuring time in minutes here, and that's all the information we need. So question A says find the value of K to two significant figures. So the reason why I'm underlining all my different variables, E is not a variable, remember, it's just a number, is to solve an equation. Typically I want to put numbers in for all of my variables except for one I'm trying to find. So I see 1, 2, 3, 4 variables in here. Okay, this one being a constant that I'm trying to find. So I'm going to need to put values in here, here, and here. So I'm now going to read my question. I'm going to see if I can pluck out those values. So the sentence here is actually quite short. It says, in 5 minutes, 20 grams of this substance is reduced to 18. So from that I'm reading that the initial value was 20, and after 5 minutes, in other words when t is 5, the value now is 18. So what I'm going to do now is I'm going to rewrite this with my values in. So there we go, I've put my values in. Rather than writing K5, I'm obviously going to write 5K there. At this point, if you're not comfortable solving exponential equations, then take a look back at the previous video, which was on solving exponential equations using E and the natural logarithm. So to solve this, I'm going to try and get K on its own here. Now I'm going to use change side, change sign. I'm going to get rid of everything else around it. So ultimately I'm going to want to get rid of this E. However, I can't move the E across the exponential base E until the whole right hand side is written as E something. In other words, I need to get rid of this 20 first. So I'm going to take this 20 across, it becomes 18 divided by 20 equals E to the minus 5K. So in a moment I'm going to be ready to take this E across, but I'm going to do two things. One is I'm going to put 18 divided by 20 in my calculator. I'm going to get 0.9, and the other thing is I'm going to swap these around. So now I can get rid of E. And if you remember from solving exponential equations, when we grab an exponential and move it to the other side, it becomes the opposite. Instead of an exponential of base E, it becomes a log to the base E. Now, we aren't going to write log to the base e of 0.9, because if you remember, we've got a special button for that, and that button is log to the base e is actually the same as ln or ln. So at this stage, from this point on, we are just solving an equation, number crunching. My final two steps are to find out what ln of 9 is as a decimal, and then I'm going to take the -5 across and divide it. I'm going to grab a calculator and get my answer. So there we go, my answer for K is 0.021, those two negatives cancel out there. So what I'm going to do is I'm just going to make a wee note of this down here. Up there I should say, and I'm going to go on to part B. So what part B is asking us to do is find the half-life of this substance. So the half-life is the time it takes for it to go from its initial value to half of what it initially was. Now, if you don't get given any initial values, then I would tend to pick the initial value is 100, and the half-life is how long does it take for it to go down to becoming only 50. However, this question it isn't important, but it did lead with an initial value of 20, so why don't I just stick with my initial value of 20? It won't make a difference. And what I'm looking for is when this value becomes 10. And my answer is going to be a time. T is what I'm looking for. Now, I know two of these variables. I actually know what K is now as well. So what I'm going to do is I'm going to rub this out and replace K with 0.021. Okay, so now I'm going to rewrite this equation substituting these two values in. Okay, and the next step is going to be solving an equation. It is going to be exactly the same steps as part A. So, give or take a bit of rounding, what I get as my answer for T is 33.01. So let's just make my answer a little bit more clear. I was measuring in minutes, so the half-life of this substance, the time it takes to get from whatever it started with to half that value is 33.01 minutes. So a couple of final thoughts when it comes to approaching these questions. Yes, they look tricky, but don't let that put you off. My tips are to get the equation copied very, very carefully onto your page, so you've got it right in front of you having copied it. You're going to sub values in typically, and then rearrange, solve to find your answer. So you should be subbing values in and leaving one variable unknown. That's the general pattern here. And with that in mind, what I would say is that if the thing that you find difficult is taking those values from the sentences, figuring out what to put in, then I would say invent some values. If you know how to solve log equations, if you can do the whole rearranging thing, but you can't find those values, you don't want to miss out on those solving equation marks simply because you weren't able to figure out what the initial value should be, for example. So invent some values if you need to, rearrange, and the chances are you'll pick up some marks. The final thing is practice. Plenty of practice at these, and I think they actually start to become quite repetitive but quite similar, quite doable.